it's me and this is my channel. So why does lift matter? For example, it determines how fast a plane can fly at a given altitude, or how much power an aircraft engine needs to generate in order to keep an airplane aloft. It also helps us understand how nature works, like why a bird can fly, or how a seed is dispersed from a plant, or even how clouds form. And it's crucial to many technologies that we use every day, like wind turbines, helicopters, and airplanes. Understanding lift helps us make better versions of these machines, which will save lives, transport goods more efficiently, and allow us to explore new frontiers. Like in 2021, for example, congratulations were in order because after decades of false starts, test flights, crashes, and other setbacks, the world's first fully functioning flying car had finally made its way into the skies. It was able to do this thanks to our understanding of lift. This machine was able to trade places between being on the road and being in the air. But this is just one example of how lift will help push humanity forward in the future. Our goal with this series is to give you a basic intuitive understanding of lift so that you can see why it matters. This is part 1 of a 3-part series about lift. Here we'll talk about what lift is and how it relates to other aerodynamic forces. In part 2, we'll dive into the mathematics behind lift, and in part 3, we'll finish by explaining how different wings generate lift. If we think about a bird, an airplane, or any object that flies, there are 4 forces that need to be considered: gravity, thrust, drag, and lift. Let's consider a bird that's flying horizontally at a constant velocity. To keep moving at a constant speed, the bird must exert an equal and opposite force against the air with its wings. This is called thrust, and it moves the bird through the air. Gravity pulls the bird downwards, and to keep the bird from falling, lift generated by the wings acts upwards. The other 2 forces are drag and induced drag. Drag opposes the direction of motion and keeps the bird from going too fast. And induced drag is a byproduct of generating lift, and it acts in the opposite direction of the lift. In order to generate lift, you need a wing-like structure that deflects the air downwards. All of these forces work together to make flight possible. Now let's imagine that the bird has stopped flapping its wings and is now falling through the air like a skydiver. In this scenario, only 2 forces act on the bird: gravity and lift. If the lift is 0, then the bird will fall faster and faster under the influence of gravity. If the lift is very high, then the bird will rise faster and faster. So in general, the greater the difference between the lift and the weight of an object, the faster it will accelerate in that direction. But how does lift relate to other aerodynamic forces? When an object moves through the air, it pushes some of the air out of the way, and the faster it moves, the more air it pushes out of the way and the more resistance it feels. This resistance is called drag. You feel drag when you move your hand through the air or when you try to push an object through a fluid. The faster you move, the more drag you feel. So increasing an object's speed through the air increases the amount of drag. Drag always acts in the opposite direction to the motion of an object. Another force that objects experience when moving through the air is called induced drag. Induced drag comes from the generation of lift and is always perpendicular to the lift. It always acts in the opposite direction of the lift. Induced drag is determined by the amount of lift being produced, not the shape of the object. So if we increase the lift by changing the angle of attack, the amount of induced drag also changes. Induced drag is caused by the creation of vortices that spin off the wingtips and the tail of an aircraft. These spinning tubes of air move around with the aircraft and induce drag. The faster an aircraft moves, the faster these vortices spin and the more induced drag they produce. Now that we know about drag and induced drag, we can go back to our bird that's flying at a constant speed. Remember that to keep moving at a constant speed, the bird must exert an equal and opposite force against the air with its wings. This force is called thrust. Thrust is used to overcome drag and allow the object to move through the air at a constant speed. If we increase the thrust, the object accelerates through the air. If we decrease the thrust, the object slows down and eventually falls from the sky. And now we're left with one of the four forces of flight, lift. Lift is a force that acts perpendicular to the wing, and it is used to overcome gravity and allow the object to stay airborne. Lift is generated by the shape of the wing and the angle at which it's held. The faster an aircraft moves, the faster the air moves over the wing and the more lift is generated. If we increase the lift, the object rises through the air. If we decrease the lift, the object falls to the ground. So now you know the four forces of flight: gravity, thrust, drag, and lift. Now you know how these forces work together to make flight possible. It might seem complicated at first, but once you break it down into its basic components, it's really not that bad. The key thing to remember is that all four of these forces need to be balanced in order for an aircraft to stay in the air. Too much lift and the aircraft will stall. Too little lift and the aircraft will plummet to the ground. Too much drag and the aircraft will slow to a stop. Too little drag and the aircraft will pick up speed until it tears itself apart. Lift is generated by the shape of an object and the angle at which it's held. The faster an object moves through the air, the more lift is generated. If an object is moving through the air at a constant speed, then the lift must equal the weight of the object. If the lift is greater than the weight, then the object will rise. If the lift is less than the weight, then the object will fall. So now you have a basic understanding of lift. In our next video, we'll dive deeper into the mathematics behind lift and explain how different wings generate lift. So stay tuned. I hope you enjoyed this video. If you did, don't forget to hit subscribe so that you don't miss out on any of my videos. You can also check out my other content where I cover a wide range of topics in mathematics and physics. Thanks for watching. See you next time.